Welcome to the module on milling applications in drilling. Today we shall learn about milling applications in drilling, milling weight, milling rates, converting SFPM to RPM, milling guidelines, box tap operations, taper tap operations. Milling applications in drilling involves the use of a mill or similar downhole tool to cut and remove material from equipment or tools located in the wellbore. Successful milling operations require appropriate selection of milling tools, fluids, and techniques. The mills, or similar cutting tools, must be compatible with the fish materials and wellbore conditions. The circulated fluid should be capable of removing the milled material from the wellbore. Finally, the techniques employed should be appropriate to the anticipated conditions and the likely time required to reach the operation objectives. Milling applications in drilling. Milling is not designed only for the fish in the hole, but it may be necessary for the following reasons: removal of tools that were previously placed in the well, such as port collars, packers, bridge plugs, cement shoes, etc. Perform a well sidetrack from the casing by doing a window in the casing, then using the whipstock. Removal of the left parts of the drill string, such as drilling stabilizers, drilling subs, stabilizer blades, drill pipe, collars, etc. Milling of drilling tools or other junk in the oil and gas wells, such as drilling bits, hand wrenches, clamps, etc. Perform a hole through the collapsed pipe. Cut casing liners, tops and broken pipes. Release special tools such as packer slips. Milling weight. Mill by torque and not by weight. Too much weight on rotary shoes wears the shoe out prematurely. As long as the shoe is torquing up, there is enough weight on the shoe. Increasing the weight will not increase the milling rate and risk wearing out the shoe. The maximum weight to run on a shoe is 1,000 pounds per OD inch of the shoe. Generally, 3,000 to 4,000 pounds on the shoe is sufficient. Exceeding of this maximum weight takes place when space rings or other parts of a packer begin to turn freely with the shoe, indicated by a lack of torque in the string. Dry drill with maximum drill collar weight until the fish locks up and begins to torque again. Let us look at the optimum milling rates based on the mill or shoe in the tables on your screen. Converting SFPM to RPM. Because there is not an SFPM indicator on the rig, convert the manufacturer's listed milling rate to revolutions per minute, RPM. We may use the following formula to convert SFPM to RPM. SFPM is equal to mill diameter into RPM into 0.262. The RPM may be derived from the SFPM by multiplying the mill diameter by the milling RPM. This result is then multiplied by a constant, 0.262. For example, a certain mill's diameter is 4.5 inches and the milling rate in RPM is 120. You would calculate the SFPM in this way: 4.5 into 120 into 0.262 is equal to 142 SFPM. With clear water workover fluids, try to get the annular velocity up to 120 feet per minute, pumping high viscosity pulsades and lifting the cuttings to the surface. Check the cuttings coming over the shaker screen to determine how the milling is progressing. One must note that milling torque will cause 8 round tubing to make up at least 1 inch per 1,000 feet of depth. Milling guidelines. 1. Keep mud yield point as high enough prior to milling operations. 2. Start rotation before the top of fish with a minimum of 3 feet. 3. Adjust weight on bit, WOB, and revolution per minute, RPM. Start with 70 RPM and monitor the torque while increasing RPM, as you are using a new drilling bit to get the best milling rate. 4. Keep the flow velocity high to have a turbulent flow for cleaning while milling and avoid the accumulation of the cuttings inside important tools such as BOP rams. 5. Never circulate through choke while milling. 6. Using jars and compression will be good while milling to help in case of sudden stuck of the mill. 7. Use ditch magnets on the shaker area to help collect the metal cuttings, keep it always clean and record its weights. 8. If the milling is inside the casing, try to make your oil and gas drilling mud lubricant enough to avoid casing wear. 9. After pull out of the hole, POOH, if the mill blades have a hook shape, this means the milling is doing good. But if the shape was tapered, it will mean that you applied too much weight which caused wear. 10. Cutting shape is important, as if it was hair-like, it means that weight shall be increased. And if it was fish-like, it will be a good idea to decrease the weight and increase the RPM. 11. Keep a record of the following: torque, RPM, pump pressure, progress made, weight on mill, recovered metal weight, circulation rate. 12. Using non-rotating drill pipe protectors will be useful across build-up and drop-off sections to decrease casing wear. 13. Use drilling stabilizers, above the mill with 1 or 2 joints, and it will be great if they have soft blades. Don't use a lot of centralizers as it may increase the resultant torque. Note: box taps and taper taps fishing tools are 2 types of attachments that are used in fishing operations to screw into a fish. Box types have threads on the ID, which cut threads into the OD of the fish, externally engaging the pipe. Taper types are used to engage the inside of a fish where conventional releasing spears would not be feasible. They can be ordered with right-hand or left-hand wickers and the normal taper is 3 by 4 inches per foot. Box taps operations. Like taper tap, box taps are sometimes used to retrieve an irregularly sized fish or a fish with an unknown OD. No need to know what kind of threads the fish has because the box tap cuts its own threads. However, the fish needs to be stationary for the box tap to be successful. Box taps are not typically recommended because they are not releasable. For that reason, a safety joint should always be run immediately above a box tap. Running procedure for box taps. Trip and hold to the top of the fish, turn mud pump and circulate any cuttings off the fish. Tag the fish lightly and rock the rotary to thread the tap onto the fish. As the tap cuts threads onto the fish, slack off while watching the weight indicator to accommodate for thread makeup. Note: it is difficult to gauge the correct amount of torque to apply while making up a tap. However, when made up properly, a box and taper tap can hold up to 100,000 pounds. Use straight pickup to pull the fish. Caution: tripping the drilling jar might free the tap from the fish. This is how a box tap looks like. Taper tap operations. Taper tap fishing tools have threads on the odd, which cut threads into the ID of the fish. They internally engage the fish, inhibiting circulation through the fish. They are usually only considered as a last resort. This tool screws into the fish and cuts threads as it goes. Cutting new threads is a more positive engagement than attempting simply to screw on or into existing threads on a fish that may be damaged, misaligned, or incomplete. New threads can also be cut on the blank pipes. Frequently, the taper tap is used to retrieve a production packer after the slip segments and packer element have been milled with conventional mills. This is how a taper tap looks like. Running procedure for a taper tap. Run taper tap into the hole and lightly tag the top of the fish. Pick up and begin to rotate slowly. Note the free torque of the work string. While rotating, slowly lower the taper tap into the fish until the torque begins to build up rapidly. Increase the set-down weight as the torque increases. Once the taper tap is firmly seated in the fish, attempt to retrieve the fish with a straight pull, dependent upon the fishing scenario. Caution: again, taps are non-releasable and should be run with bumper jars and safety joints. Taps should only be used when releasable engagement type tools are not an option. Thank you for learning with us.